I'm Stephen Foskett, the organizer of the Tech Field Day event series, and we are here in San Francisco. We've brought in a group of independent writers, speakers, bloggers, podcasters, people who are influencing opinion on enterprise IT equipment to talk with companies in their space. The videos you're about to see are a discussion between our Field Day delegates and companies, including Avere, who we have presenting now. If you'd like to learn more about Tech Field Day, go to techfieldday.com. You can learn how to be a presenter or a delegate at a future event. You can also find lots of our videos on youtube.com/techfieldday.
My name is Scott Jeschonek. I'm the Director of Product Management for Avere's Cloud Products. I run the software roadmap and work closely with other team members on the hardware side, et cetera. And I also work very closely with my partner in crime here. Bernie, you want to introduce yourself?
My name is Bernie Behn. Most people call me Bernie. I am the Principal Technical Marketing Engineer at Avere. Primarily, I spend a lot of my time doing performance validation, solution architecture, and integration with other software vendors on our product side with customer use cases.
Okay. And what we're going to talk to you about today, I have a slide deck that puts together a couple sections, which you guys see on your agenda. First, we're going to talk about Avere Systems ourselves. I think some of you have heard this from us before, but we'll go over sort of why the company exists and how it's grown over the years. We're going to talk very specifically about where Avere is playing the most today, which is hybrid cloud NAS, a term I think we would take credit for coining at this point,
I hope so.
among all the other terms out there in storage. But it's a very interesting and exciting place. It's the congruence of where a lot of things are happening. So we're going to talk about that, and we're going to talk about how Avere's technology is used to address some of the use cases. And then we'll get into not only talking about the use cases in a hypothetical level, but talking in detail about some of our use cases. We have some good slides put together for a couple of the verticals that I think you'll find interesting. And then we're going to talk a little bit about one of the new products that we're going to market with, or that we've gone to market with, which is our C2N storage. I think the rules of engagement are you guys ask questions throughout at will, right? So please.
Engagement, there are no rules.
Yeah, right, exactly. So there's an absence of rules, and so in the absence of rules, please feel free to speak up and ask any questions that you have. And let's jump in here. So why not have another marketing term, but it's a good one, tiered file system. So what is Avere's technology at a fundamental level? We do tiering of data. When Avere started, one of the primary reasons for its existence was in Hollywood, in media and entertainment, not being able to access the data fast enough off of the NAS environments that they had to keep up with the demand, and the ability, quite frankly, to add more and more server capacity. It was just outstripping. Yes?
Can I ask you a very early question?
Absolutely.
You said tiered file system, but aren't you a cached file system?
I would love to say that we're a cached file system, but the slide says tiered. No, yeah, I mean, essentially at one level we are a caching mechanism, but architecturally the product has evolved over the years to go beyond just caching, and I'll get into a little bit of that.
Cached and tiered file system.
Yeah, but that's like too long of a nice. It's not catchy enough of a marketing
Not really,
phrase,
no.
right? So, and you know, our team basically consists of a lot of people that have been in file systems for decades. Ron Bianchini is our CEO. He was a professor at Carnegie Mellon, has started a number of companies in the storage area. Spinnaker was one that got acquired by NetApp, and so he's got a long history. Our CTO is Mike Kazar, who wrote the Andrew file system. And then they're surrounded by a team of development folks that come from, you know, a long history of storage from different companies, NetApp and Panasys and other places. And ultimately, our product has evolved into what we call sort of a purpose-built hybrid cloud NAS solution. Who uses Avere, right? So this is a splashy slide that kind of gives you a feel. What I like about this slide, aside from sort of the braggadocio of like 8 out of 9 and 2 out of 3, is the fact that it spans verticals. And so I've been with Avere now for over 2 years, 2.5 years, and what really stimulates my interest in what we do is the fact that one day I can be talking to somebody about, you know, bioinformatic workloads and how they can optimize that, and the next day I can be talking to a quant team about how they can speed up the number of you know, analytic routines they can process against their NAS. So it's a very diverse addressable market for us, which is always a good thing, because that means that Even though we've been really successful in media and entertainment, it's not our sole vertical, and in fact, it's not the percentage, if you will, of just media and entertainment has gone down significantly over the years. We've really spread ourselves out into different verticals. Gratuitous logo slide for you all. It was part of the stock deck, but I mean, again, if you look at it, there's a lot of good names in there. There's some interesting use cases that we'll get into later on today, such as H3 Biomedicine, based out of New England. And the use cases in all of these, even though there are a few really core use cases that we really shine and excel at, I can't help it.
Sorry about that.
I just can't help it. By the 7th time they come around, it'll be boring and we won't pay any more attention to them. Oh my gosh.
That's real.
Wasn't it? It was great. All right. Sorry. So we talk about this hybrid cloud. So what does hybrid cloud mean in the way that we're presenting it? So, and I think that's a good caveat because you guys are all over the field. You know this stuff inside and out. You know what people are doing, not just in storage, but in compute. And because of that, there's so many different ways for people to do things out there. And there's not one best way to do anything. And so this is our perception of what we are talking to customers about. And the customers we're talking about are interested in things like this hybrid cloud. So the premise behind hybrid cloud is pretty straightforward. Customers have traditional NAS environments. And there's nothing wrong with that traditional NAS environment other than it takes up space. It can only grow so large compared to my CapEx and OpEx budgets. I only have so many staff to deal with it. And I'm continuously seeing massive growth of compute infrastructure and application infrastructure that suggests that perhaps I need to start either A, expanding my data center, B, maybe looking at new technologies for my data center, perhaps going down the hyperconverged road, or C, looking at some of the public cloud providers, or D, a little bit of some of or all of them, right, and spreading out into the different solution sets. And really, the compute demand is what's driving it from the customers that we play a lot with. I mean, it's just so easy to add a lot of compute. And now that you can go into Amazon or you can go into Google or Microsoft with a Python script and initiate 1,000 servers for a few hours and then wipe them out, right? Suddenly the whole rules of physics have changed. And so, hybrid cloud then is a big question because previously the question that you had with cloud was, are you going in or aren't you? It was a very Boolean discussion. You're either going to put a strategy together, your C-level has mandated that everything's going into the cloud effective some insanely short period of time, right? Or they've said, we're never doing cloud ever and don't ever talk about it because who knows, right? There's biases, there's concerns about security, there's all kinds of different things. And there's also just, this is the way we've always done it. And that's a perfectly reasonable human reaction to it. But hybrid cloud is really what we're starting to see a lot of increase in, because what people have found is it is so easy. The barriers to entry into the public cloud and into compute is just so cheap. I mean, all I need to do is code, and I can, and of course, have a credit card or something like that, right? With a very large, but because sometimes you get carried away. But it's just too easy to do, and so the barriers to entry just don't exist there. Whereas the barriers to entry to expanding your data center are very real, aren't they? There's leases and there's other things you have to consider. On the other hand, I've already spent money. I already have substantial policies in place with regards to how to handle all of my physical infrastructure and my software and my operating systems and my code bases, et cetera. I have staff that are trained in that way and so on. And so, or you can take it a different way and say, I'm in a regulated environment and I have privacy concerns and I have security concerns. And these are all very real to these organizations, that it's not a matter of just going all in or not at all. Because those organizations can still benefit from the use of these public cloud environments. They just have to be more conscious about how they distribute assets between the two, right? So the business benefits, and I promise you there's not a lot of these types of slides. We'll get straight to the
this
tech.
is good. I like this.
Are you sure?
personally.
Okay, that's fine.
Or you can do as many of these as you want. I'm okay with it.
Oh, I have another deck that's no. It's all like pie charts and no. So,
yeah.
animated even. All right. So the benefits really of hybrid cloud are being able to onboard certain assets in the public clouds. Being able to say, you know what, I'm going to do an HPC cluster in Google, right? But not have to take on the technical and most certainly the political challenges in your organization that convince them that all of the data can go happily up into the cloud with it. You can bypass that problem and start really taking on the benefits. I have to pause for a second for the jet engines to quit bouncing off of the building. You can take advantage of those assets without having to really, overinvest in convincing people that everything's got to go. And for the public cloud providers, I think Amazon and Google and Microsoft, these guys would love for a company to just put everything in and be done with it and use artificial intelligence and Internet of Things, and we're in a new paradigm today, right? But the reality is that there's those organizations, the insurance companies, the banks, et cetera, that aren't necessarily going to just do that, right? So the benefits are really, I can get going quickly. I don't have to worry about, the biggest thing I have to worry about in that equation is probably the network. Getting networking from my site to Amazon or my site to Google through whatever Equinix data center or connection that I can.
Physics.
Yes. Yes, physics come into play, and we'll talk about that a lot. Lower cost. So ultimately, I can sort of stay the course with my on-premise NAS environment as it is. I don't necessarily have to grow it to start using the assets in the cloud. I can expand it. I could even then start to think, well, I'll use it and I'll use GCS or S3 for certain types and classes of data. And so it gives you really the ability to play the cost game with this. In fact, one of the trends that we'll talk a little bit about is that there's an old rule, I think, in IT, and I could be wrong. I come from the networking world. So you had a Cisco shop, but the Cisco shop always had, I don't know. I don't want to name an off-brand vendor because I'll date myself, but a smaller vendor, right, that they would bring in for the 20% of the business. And the idea would be I always have some leverage then against my 80% vendor if I need something done, right? So I can always play that game. I think you're starting to see similar patterns of behavior in the public cloud environment because barriers of entry are pretty low. I can have Amazon and Google up if I want, as long as I'm networked. Simplicity. So with hybrid cloud, one of the big things that we also hear a lot about is, again, this is, it went from are you in or aren't you? You're either with us or you're against us, to now it's a little bit more nuanced. And one of the barriers to entry in using cloud for storage has been the rewrite problem. So the rewrite problem is I have NFS, I have SMB protocols, and I have applications that use those and have been working with that for years and years. I have processes built up around them. I have workflow built up around them to just make a trigger decision that I'm going to rewrite it in absentia of the entire workflow. I'm just going to change that so that it can talk object has been a barrier. It's a real problem. And especially because this isn't like a Y2K style problem where you had to, the perception was if we don't rewrite our applications, electricity will stop flowing, satellites will fall out of the sky kind of thing, right? This is more, you can go into object storage, period. I mean, what are the advantages? Well, you have endless possible amount of storage if you wish. All you have to do is rewrite your applications. So what Avere offers, and what we'll get into a little bit, is a POSIX solution to that problem. So you can still use your object storage, but you don't have to rewrite your applications today. And if tomorrow you decide to reconstitute your architecture to be completely object, completely in the cloud, that's fine. You can go and do that. But this gives you the ability to start sooner and overcome that particular obstacle. And then the flexibility. So being able to, we have customers today, and we'll talk about this in the use cases, that do a lot of their work in the compute environment of a public cloud. All their data is still done on-prem. And there's a lot of reasons for that. Okay? My first animated slide. I apologize in advance that it's animated, but There we go. So what did we start doing as Avere? Avere's claim to fame initially was NAS optimization. Pure and simple, compute was outstripping the ability for the storage. There was latency with the storage that was unacceptable to certain verticals, such as Hollywood render shops, who were increasing their ability to add compute power. And so the choices were, I can invest more in like my Isilon heads, I can invest more in my NAS in general. That has sort of a law of diminishing returns in terms of cost, and I think there's some scale issues once you get above a certain amount of connected clients. And then ultimately, I could choose to do something different, which would be, as you had mentioned earlier, caching the relevant data in the hottest place. And so we started in NAS optimization, and predominantly in front of a lot of Isilon and a lot of NetApp. It's actually beneficial to the Isilons and the NetApps of the world because it takes the negative pressure off of the customer to have to consider a full change of infrastructure, right? Because the choices were you could radically expand your physical NAS infrastructure, which was a cost problem. You could use Avere, which gives you a different cost. It's not the expense curve of what expanding your NAS would be. Or you could go to another vendor altogether and replace everything, which is undesirable for everyone. And so that was how we started life.
It was essentially, or is essentially, caching for that local NAS.
Absolutely. Okay. Like the first product, if you will, was us, the core filer, the NetApp, NFS, right? Out the front, NFS. And basically, we would cache the most relevant data, okay? So then the next step was, in the search for alternate storage methodologies comes object, right? Unstructured object storage. It started really, I'm not quite clear on the history, but I think it started with Amazon, it's safe to say, right? And then the on-prem story started to bubble up where I think some upstart vendors, if you will, and that's not meant in a negative way, it's just, they saw a way to potentially disrupt the storage market that has long been dominated by EMC and NetApp by coming in with this low-cost, high durability, solution called object storage. And there were several vendors that came out to market. I think we're in the offices of one that has come to market. There's some challenges here, though, right? Again, the same problem exists that you have to rewrite your applications if you intend to use it in your workflow pipeline. And that was perhaps not attractive to people. And also, it was fairly new, if you will. So the technology for object, it's older now, but at the end of the day, it was fairly new, untested. Performance was of a concern, other things. Bless you. And so the question was, and what we found was a lot of object storage vendors would come to us because customers that were looking at them were wondering how they could get NFS to talk to this object store, right? And so what we did is we extended our product. So this is the first extension beyond just caching, okay, why don't we create an abstraction for object? And there's a couple slides down the line here that Bernie's he'll dissect how we do it and talk to you about the sort of underlying architecture. And so we built basically a file system abstraction over object. We basically treat the object store as blocks of storage that we then put data on. But from a client perspective, they see it as NFS, they see it as SMB support.
And again, is it a cache or is it a copy?
In this scenario, case, it's now a file system. So actually, we are the owners of the file system structure.
Yeah.
And then we figure out what doesn't fit in our quote-unquote caching tier, and that's what gets pushed out in the form of objects. So therefore, you have your discrete tiers of the file system owning cache layer, and then the cold data object storage layer.
The best way I've found is in the traditional, this is the NAS, meaning this is the functional NAS. Mm-hmm. In this world, this is the NAS. Mm-hmm. Mm-hmm. Right, and then we abstract the data back onto the.
So what object. Was the design decision to go for chunking the data up and putting it into the object store in units of storage rather than putting in a one-for-one file relationship? Because clearly one of the problems you have is you can't easily now go back to the object store and access that data directly because it's not in a format the user can read?
That was on the top of my list of anticipated questions
Okay.
that you guys would ask. No, it was number 2. So, couple of reasons, and we'll bounce back and forth on this. So the key number 1 reason is when we first built out support, and this slide is a little misleading, I understand. When we first built out support for Object, we actually worked with Amazon. And in discussions with Amazon about best practices for optimizing performance, because again, we come from the performance wing, if you will, of the equation, they recommended more discrete objects of a more uniform size and prefixed in certain ways to optimize its spread against, if you will, their fabric, right? And we took that and we implemented it and we tested it, and the performance numbers are quite good. And I'll pause there if you want to add to that.
No, yeah, well, I think that's definitely the first one. I mean, I think the second main driver for that was to achieve full POSIX compliance in terms of, having applications that expect the ability to create hard links, to rename directories that occur instantly without having to rewrite a bunch of objects on the back end. Being able to move one entire directory substructure into another subdirectory without piecemealing each object over. So those were some of the main drivers in terms of why we went in the direction of chunking up the data in the Amazon, but absolutely does present the challenge of now you have chunked data that without the Avere is much more difficult to interpret. But that kind of dovetails into our next evolution of this hybrid cloud vision, I guess.
Yes.
And maybe I could add one that you'll probably discuss perhaps, but something we said on the previous presentation. What would happen if we got rid of your appliance? We lost it or something happened?
Here's what you do. Yeah, that's a great question, right? The question is, and this was a big debate we had, it's like people are going to feel trapped, right? But you're really not trapped. It would be the equivalent of migrating data through a couple mounted clients, and you were using Fuse. It would basically be you would mount through, you'd mount our export here, you'd use some clients with wherever you're intending to put it, right? And if you're putting it up here, you'd use an S3 copy tool, and then you're done.
Okay, I was less meaning that, more of a case of what happens if my appliance dies.
Oh, yeah, well, that's easy.
Okay, So talking about like how we own the file system structure in this object case.
Yeah.
The entire file system structure that we are aware of, right, that has been created by clients, the root of the file system, subdirectories, permission, attributes for each file, all that kind of stuff is actually pushed out to the cloud and persisted in the cloud.
Right.
Yeah.
So if you lose an entire Avere cluster to some disaster, you actually just bring up a new Avere cluster, point at your bucket. If you're using encryption, obviously you need the encryption key and that kind of stuff.
Yeah.
But you point at the bucket, we find the root of the file system, and we start populating our directory structure. And then now your clients can actually now navigate, and obviously all the data that they're going to start reading is going to be cold, which then needs to be fetched in the form of the objects, populated in our cache, and then essentially the metadata structures are the ones that populate first because that's required to get to a file, and those remain persistent in our cache from that point on.
That's the biggest penalty you pay is the cold read. So the whole thing can go away. The only caveat, as he said, was if you encrypted, which you probably did, make sure you either you retain the key or using KMIP, which we also support.
So that answer seems to contradict with my understanding of your previous answer, which was that you're only putting the cold data in the cloud. I think.
Well, I mean,
all data goes to the cloud.
Yeah.
All of it, 100%. The only data that stays resident is data that was put there through client requests. Yeah. So 100% of the data is resident in here, right? And we're fronting it. Now a client comes up, mounts us, and asks for some file. That file's data will be put in our cache.
Right.
But the actual file exists here. And if there's a write to that file, we reconcile that right back.
So going back to his original question and my sort of repeated question, is this any different than a cache? Or is it really a tier? If it's not really a tier if
it's not contributing persistent capacity.
Wow, that's a really nice.
Very well said. Very well said.
Yeah.
Nicely done.
No,
Nicely done.
That's absolutely right. So we essentially, as part of our functionality of how we chunk the file system data out and put it in the form of objects, we actually have a configuration value that we call our write-back timer, which is essentially how much persistence you want locally on the system. Right. So let's say you have a job that creates 1 million temporary files over the course of 6 hours, let's say. and writes data to them. Then they all share that data, perform some reading computation, or whatever, and then write out some results, and then they delete all those temp files. If you set your what we call a write-back delay out to the 6 hours that it takes to run this job, that transient, non-persistent data that the clients are temporarily creating never actually gets put out to the cloud. Now, if you forget to delete the data, we're eventually going to either hit that timer, or we're going to run out of cache space on our system. We're like, okay, we can no longer hold this data that clients wrote to us that we've acknowledged to them. We're going to now push that out to the cloud and mark it cold in our cache, essentially.
The tricky part of you are making a very fair point, and that was a very good way of putting it. Like, we aren't the persistent storage permanently.
No, but you're persistent for a period of time, so therefore you are contributing to capacity for a period of time.
Yeah.
But you're also,
and if
once that expires,
time,
then you're straight up caching. So
yeah.
you're both right, guys.
I like to think of our product, at its top use case, our product is basically a killer of latency, is the way to think about it. We put the hottest data as close to the compute as we possibly can. That's our best and first use case. And then from there, we have had situations where now we're abstracting this object storage into a file system, and it happens to take on this sort of dual role, right? But people are still using it as both a cache in that case. We have enterprise customers that use it so that they can have continuity of business for their file-based applications. But it's not quite caching, it's just access at that point. I'd like to use S3. I'd like my clients to not have to be rewritten for S3, so I'm going to use Avere to provide that access. Make sense? Mm-hmm. And to just put a fine point on that other question, you can blow the whole thing up, and you can put another one in its place, and you're back in business. In fact, you can blow it up.
Is the persistent window of what you're talking about.
Sorry to be a pain. Because it's a cache. I haven't heard tiering yet. Going back to your title slide, I haven't seen tiering yet. It's a cache. I'm just waiting for the tiering part.
Well, so I mean, maybe it's.
I have a slide.
Issue.
I mean, even the thing.
No, I have.
So
that's fair.
You mentioned earlier was caching rules. Those aren't tiering rules. Those are how quickly do you want to dump the cache, right?
Yeah. It's a fair question, and in fact, the way that we articulate tiering is coming up on the hardware slide.
Oh, okay.
All right, so I'll wait for that.
And then you'll look at that and you say, that's not tiering either, but that's okay. At that point, we're just going to go with cache, and then we're moving on. It's all good. All right. So the next use case was, we did some work with Amazon in a preliminary way. We were working mostly with a lot of the private object storage guys because, again, they're trying to take market share in a file world, right? And if you ask me, point blank, do I believe everything's going to turn to objects someday? Yeah, sure, it's going to turn to objects someday. When? It's anybody's guess, right? Will it all? No, probably not. Like, you're not going to take something that's been running for 20 years and rewrite it just because you can, right? And so there's going to be this period of time where there's transition. In addition, though, the Amazons of the world, the Googles of the world, the Microsofts of the world want all of the data. They would like all of your data now if they could get it all, right? Amazon came out with Snowball. You're familiar with that? Awesome thing. Like, you can kick it off of a building and the Kindle on it will still give you the shipping address, which is just so cool, right? But why did they invent that? It just seems kind of counterintuitive to the whole ubiquitous ether-like cloud, right? Well, it's because people were not bringing their data in fast enough, right? So how do you get the data in? That's been a challenge for them. And so one of the things that we hear from customers is, we would like to leverage, Amazon or GCS with Nearline because the price points are interesting. But all of our business is still down here. All of our business is on desktops or in compute centers. So we'd like to perhaps use it as an archive and put a lot of data up there. And then subsequently, we'd like to be able to access that data. But again, most of our applications, if not all of our applications, they're still expecting to mount a file system and go grab files and work on that. And so, yeah.
So there's questions in the Slack channel about what this really means. Sean.
I'm still trying to map the data path on this thing here, because some people say tiering, some people say cache. I know we're a little confused on the terminology. When data comes into this, is it immediately copied somewhere else outside of the appliance, making it a write through?
So does
the data live on that and only on that for some period of time until it's put somewhere else?
The
Latter.
latter,
Okay.
right? So this sort of highlights what happens. So data is written to what the clients think is just a mount point. The data is brought to the Avere. The Avere caches the data. Gotcha, right? It also puts it on an NVRAM card so that if something happens to one of the boxes, and it shares it with one of the HA partners in the cluster. After a period of time or immediate, it's really up to you how you want to configure it. It will eventually commit those writes to the back end.
And that's what makes it a tiering appliance.
I like the way you said that. Yes, it's tiering at that point, right?
Yes.
No.
Yes.
It's still right behind cache.
We'll argue later.
On
Is
other
this the
hand-
equivalent? Is this the equivalent of like a
I think this depends
controversy?
on which storage vendor you grew up with their definition.
Well, yeah, I think a lot of incumbent storage vendor tiering approaches involve stub files and things like that, where you're like, oh, this is no longer where I thought it was. I must go find it somewhere else.
Stubbing is completely different.
Okay. Then
Oh, you've introduced a new
we will
variable
strike
in
that
here.
from the record.
Is it caching
Further
or
add-
stubbing or
to not add
tiering?
a third term.
Okay.
Stubbing's different.
So the way you described it, though, was how it works. The data is written. The clients have no idea we exist. We eventually will commit that data back. You could arguably persist that data and some read data forever if you want on our box, but we aren't the NAS persistent layer. We always write back to something.
And you said that if they set the timer to 1 billion minutes,
It'll just sit there.
right? But you're doing some kind of local data protection so they don't do something stupid.
Yeah, it's written across. Yeah, we run in a cluster, and I'll get into that in the architecture. Right. But I think one thing will clear it up. We don't do policy-based movement of data to other places, if that makes sense. All the time, like an always-on, like, oh, this is a PDF. I'm going to put it in some special container somewhere else. We don't do that.
So it's strictly just a time-based thing?
Yeah, it's based on demand and
Activity,
time.
yeah. Activity and time.
Is that timer reset like every time it's read?
Yeah. There's lots of timers in the system to help make sure that all that works.
So it's a tier that thinks like a cache.
I love it. Yes, it's a tier cache.
Can we
It's a new. It's
move on?
it's a new marketing term. It's the tier cache. I like that. All right. So moving on though.
We're going to move things to the cache tier later.
Okay.
And then
so this is what
that's
keeps it
different.
lively. All right. No more planes. So we had to do something. All right. So the next part of the use case is we're working with Amazon. We're working with Google and these guys. And we've, ideally, the dream for the public clouds is take all of this and put it all up here. And I don't know if it'll eventually get there. I mean, it is what it is. But we have a lot of people out there that are saying, I love this compute farm, and I want to use the crap out of this because it's amazing. But I really am more comfortable down here keeping things. What can you do for me? Insert public cloud provider here. And so in working closely with these guys, we actually took our intellectual property that we run on hardware appliances, and we ported it to virtual instances that run in Amazon, that run in Google, run in Microsoft. And so the use case there we call cloud bursting. That's a form of tiering and caching that involves stubbing. No. So cloud bursting, this is more of a pure cache play here. And the name of the game is kill latency. And the idea is give the customer the flexibility of maintaining their primary data back here while only bringing up requested blocks of information to the compute environment.
You're basically just
for
going the
compute.
other direction.
Huh?
It's basically just going the other direction.
Yeah.
I mean, that's it.
Yeah. And it sounds so trivial, but there's customers out there running tens of thousands of cores for hours, if not days, in one of those public cloud computes against an Isilon. And they could not do it without the Averes in the mix.
Yeah.
That was a shameless plug. I'm sorry. But it's true.
It's true.
I am curious about the bill for doing that, like
The cost.
the
Yeah.
cost from Amazon to.
That's a great question. So this isn't our bailiwick, but let me explain what these guys look at doing. So with Amazon and with particularly with Amazon and Google, I'm not keeping Microsoft out of this. They have these different ways that you can purchase compute time that are more advantageous than, if you will, the list price, right? In Amazon's case, it's called the spot market. And in Google's case, it's called preemptible VMs, Okay, and it's all about compute at that point. And the idea is, at periods of low demand in certain regions, at certain data centers, that compute is just sitting there idle. So it makes more economic sense for one of these guys to sell it for pennies on the dollar, I'm using a turn of phrase, than the list price. And so what a lot of these guys will do, and I can't really name customers, but there's like a customer that this is the only reason they're using the public cloud, is that they can leverage the spot market and the preemptible VMs to get cheap. We're talking, the type of compute that we're talking about could be $4 an hour down to like 10 cents.
Wow.
Right? And so but they can only do that if when the spot market is optimal, they have the working set data here, or at least can get it there fairly quickly so that they can take advantage of those market prices at that time. Does that make sense? Mm-hmm. And the way that these clusters work, nodes can fall off. It doesn't matter, because the way these spot market and preemptibles is once the price exceeds a certain ceiling, it'll just be torn down until the next available price point.
And do they generally, and I guess this would be based on the workload, do they generally leave that copy up there?
No.
Or do they just let it go?
It depends on their working set requirements at the time. So like if they're doing a movie and they're going to be doing a lot of jobs consecutively
Say a movie
sequence.
about Blue Angels.
About Blue Angels flying around. Yes, it's distracting me again. Yeah, they may, like, their whole thing is assets. And so they may keep a lot of the assets they need for rendering the next scene in place. But one of the things that they really like about this is that they can bring it up for job X. And then when they're done with job X, they issue a couple of commands. These come down and the Averes can come down. We can be transient too, as long as the subsequent time, the next time you use it, you're okay with the cold read latency, the initial asks. But because of our caching algorithms, we read ahead and we build up the cache quicker than you would if you just asked for the data. You want to add something?
No, that's perfect. I think the ability to prime the cache faster after someone tore it all down is.
Yeah, and I just get on a roll. So if you want to butt in, please, by all means. So the last thing that we do in this diagram is pure cloud NAS. So this would be if you are using the compute environment for some sort of workflow. I'll give you, it could be straight up cloud computing clusters, right, based on Hadoop or something of that nature. Or it could even be like in Amazon. Amazon has this thing called workspaces, which are basically desktops in the cloud. And what if you want to just have your SIF shares accessible, but you want to use this as your actual storage entity? So then you could bring up in that last case where it's just these workspaces, that's not a high performant use case. So you could bring up a small cluster.
Nomenclature, you said SIFs.
Oh, I'm sorry, SMB.
I mean, Steven,
SMB. No. I was just reading about this. SMB, straight up. We have this problem internally because, SIFs was one thing at one time, a long time ago.
Steven wouldn't let you out of the building without correcting that.
No, it's fair. Fair point. I've been training myself to only speak SMB. But we still hear SIFs a lot. Okay, so then this would be the cloud NAS play. Again, it's really the same as the file storage for private object down here. It's providing access for POSIX, but using object as the actual storage. Okay, these are all sort of the application space that we play in. If you had to break it down, it's really like NAS, archive, and performance caching are the three main classes of solutions that we look at here. Okay? Before I move on to the next slide, any questions? All right. And I was worried we wouldn't have enough slides. Jeez, I could add one slide, would be all right. Okay, this is the edge core architecture. This is just driving the same point home that we've been talking about, which is the idea is to put the Averes closer to your clients and away from your storage, because we would allow you then to take the latency. Because we're doing read-ahead caching, for these requests, and we're doing write behind. And the write behind we do basically acts the clients near real time so that they can go on and continue working, and then we eventually fire the write timers back. And that constitutes us being basically an edge filer in this architecture. The actual core filer itself would be like the NetApp or the Isilon or the Clever Safe or the Scality or something in the back, okay? All right, who do we work with? Animation. All right. So we have our virtual machine ported into all three of these main clouds. We work with Amazon S3 and Google Cloud Storage today.
What, no Oracle?
No Oracle.
Is that on the roadmap, seeing as they've now taken over cloud?
Yeah, they've taken over cloud.
Oh, have they?
Yeah.
That's what Larry
It's
said.
good to know. I didn't know that they had.
Yeah.
But,
Yeah. Amazon is 20 years behind them.
okay.
At least they did it.
All right.
They did.
So.
Larry said.
So the private guys, predominantly, we work with HGST, which was Amplidata. Like we had worked with Amplidata very closely before, and so when HGST acquired them, we've continued to work with them. CleverSafe, which is now, of course, IBM, and we do work with SwiftStack. And then there's this Avere C2N, which we'll talk a little bit about towards the end. And then from a legacy NAS perspective, I would say the bulk of our deployments are against Isilon and NetApp filers. And then everything else sort of falls in behind that. But those are the bulk of our deployments. Okay, which makes sense, right? Aha, tiered file system. There it is.
I'm waiting.
It's tiering within. It's tiering within the product, not without the product. Bernie, you want to talk about this?
Absolutely, absolutely. So the whole idea of this chart that we've drawn here is basically you have a 3-node cluster. Those are our either our virtual appliances or our physical appliances. They're all talking to each other like they're 10 gig interconnected. And essentially, your client access is coming in from the top. So obviously, we have 2 tiers inside of our box that we call the RAM tier, which is essentially where we put all of the read data that clients are reading or recently written data that has been committed to our local SSD or SAS. Also sits in RAM if people are continuing to read it. So if you have the kind of workflows that entire farm of clients are hammering away on a certain file or a certain range of a file, we have the ability of keeping that in the RAM to serve it up very quickly. The other case is if a client comes in and writes one file and then 1,000 clients come in through the other nodes and start to read that file, we do a level of horizontal tiering and then pass the data of interest up the stack into the RAM. The whole idea here is basically whatever doesn't fit in our SSD layer is what we end up pushing into the core or into the core filer. So be that object or be that NAS. The other idea is anything that clients are requesting that maybe hasn't been seen by our cache in 6 months, a year, 2 years, right? That's typically not going to be warm in the cache. So when the client request comes in, he's able to navigate the metadata, find his file. But if the file data is not there, we have to request that file data from either the NAS core filer or the object core filer, in which case it gets stored persistently in our SSD layer. And then as clients actually start to really read that set of data, or if they're just reading it once, it's going to pop in RAM and then pop right back down because there's actually no reason to keep it up in there. The idea here is that we can scale out up to 50 nodes, and we share the cache capacity across all the nodes in the cluster. So instead of going with either focus all of your I/O for a single file on a single node, or spread the data for a single file across all the nodes in the cluster, either one of those has drawbacks, right? So the focusing will give you hotspots. The spreading out across all nodes of the cluster is going to give you inefficient utilization of your cache resources. So then we have these, these software processes that run inside and basically are looking at who's accessing what and where, and then make the decisions of where we're going to replicate certain pieces of file data across different SSDs or different RAM pools on the given nodes. And the idea is that we can sit in front of up to 50 different core filers. So you can have a NetApp, an Isilon, a ZFS box, an S3 bucket, a Google Cloud Storage bucket, all those things tied in behind our infrastructure as core filers, and then you can use our global namespace feature, which basically allows you to create, for lack of a better term, like a symlink tree to redirect the client request to each one of those based on the paths that they're trying to access.
And each node can handle a lot of concurrent NFS access. We're talking 10,000 NFS connections per node simultaneous. So you can scale this out quite a bit. Any questions about this slide?
What happens to new files?
So you're saying if a new file create coming in from a client? Mm-hmm. So essentially what ends up happening in those cases is the client comes in, sends a create, we create the metadata structures. If it's an object file, if it's an object-backed file, if it's a NAS-backed file, we send the create call down to the NAS because he's the guy maintaining the actual integrity of the file structure. In that case, we hold on to the create data, the metadata for that, the inode, all that good stuff, and then the client starts to populate data in there. So he writes data into that file. Each node has a designated partner in the cluster of where he's sending a replica of that data to handle node failure, disk failure, system failure, essentially. And then as the writes come in and get sent off to your HA buddy, we respond to the client write request affirmatively, and then at that point he can continue and move on. So that's what we call the write caching effect, in which case once you're running out of write cache space, i.e. if you're dumping a lot of data into the system, or if your timers are set particularly low, then that data gets purged from the write cache portion of our resources down to the core filer. But if people are continuing to read it, we're actually still going to keep it around in our cache at that point in time to serve up the subsequent. So that's kind of the act of tiering down as a file is written and pushed down to the core filer, or if it's cold in our cache, we end up pulling it off of the outside of our box into the box.
Okay.
Something I haven't asked, I didn't ask earlier, but might be relevant. I don't know. When you're scaling to the cloud, like you were showing, how do you manage locks on files over distance, or do you not bother?
So no, we actually do. We have like a relay agent that sits in our virtual appliance for lock state. Right. So essentially, a client comes in and requests a lock on a file. We're going to send that lock request down to the core filer. In which case, if that's like Isilon, let's say, then he's going to have a lock on that file, so that if someone were on-prem trying to access and take a lock on that same file, he would get denied. Okay. Or if someone else in the cloud tried to take a second lock on that file, he would also get denied. And then when the lock is released, it gets propagated down to the core filer and then released all the way back up the chain. So you can't really mitigate latency in that case because it's more of a synchronous action.
Well, yeah.
But obviously, locks are much more infrequent events than general file I/O like reads and writes.
Okay. The protocols. So this just sort of, we've talked about this. This just drives it home. What do we do on the front end when we're listening for clients? It's NFS v3. It's SMB 2.1 is the current protocol we support. On the back end, traditionally, it's mostly going to be NFS to the legacy NAS environments, although we do use SMB for metadata ops management. The reads and the writes are done at the NFS level. For private object, we use predominantly S3, but recently have been doing proof of concept around using native Swift as the access. And then for the public guys, it's all S3 at this point. Okay. The global namespace, which Bernie was talking a little bit about.
Go back just for, you said you were looking at doing native Swifts. Why?
The performance. Go ahead.
Yeah, no. So it's mostly around the performance of the API handler on the Swift stack. Yeah. They added an S3 compatibility layer, and there's some overhead to the request that it has to process in terms of unmarshalling the headers and things like that. Oh, so they're more efficient if we can send
Swift. If I'm writing a Swift, it's faster to use their native than to...
It uses less resources on their...
Is it faster than a competitor to Swift?
Yeah, so that's not an inherent Swift issue. It's a Swift stacks
S3 implementation issue.
Yeah.
Yeah. Okay.
Okay. The global namespace is the thing that Bernie mentioned earlier, where I can create a namespace based off of what we call core filers, which would be, for example, an export on a traditional NAS or 10 exports. They could be, directory attributes in the namespace. I can have buckets either in the public cloud or in private object, and those buckets will be represented as a directory out here. I can also do the subdirectory junction, which means that one of the things that we found here is that people want to do sort of export rules below the bucket level. Like, for example, they're a research shop and they want to parcel out and protect certain areas of their NAS that doesn't exist up here, right? Based on export policies. And there's nothing in object that allows you to specifically do that in that way. And so we actually allow you now to basically do an export policy on a subdirectory that we know about as part of our persistent state that's related to these buckets. It's a little bit long way of saying,
enforcement essentially at a subdirectory level, whereas normally under a normal, let's say like a NetApp, right, you export vol1, you put a policy on that, right? And if you want additional subdirectories, you have to create Q trees and put policies on those Q trees. So the model is customers that were accustomed with that type of deployment said, well, great, we want to move our data to the cloud, but all you were able to offer us was a single export.
At the bucket
that would just be slash, and then the customer starts dumping data, and they're like, well, that's not going to work for us. We need the kind of Q-tree ability to peel off subdirectories and have different export policies on them. So that's a functionality that we just recently added that allows a lot more flexibility for the multi-project type.
So these policies would be something outside of your product?
No,
They're basically access gates. So a client comes in and tries to CD down to one of these things, and there's a rule that says, like, all right, you have to have this IP address, or you have to be authenticated as this user, or inside of this net group to be able to have access to those resources, which is typically
access policy. Is that what you mean when you say export policy?
Yeah. Export or access policy.
Okay.
It's like essentially the analogous of an Etsy exports on a.
Because I was thinking you were. Okay.
Very similar.
That's it. And the reason we did that is because then that allows them to do all of their policies within a bucket instead of having to spread out across multiple buckets.
Right.
Just a more advantageous way of dealing with it.
Been a while since I hacked an Etsy export file. But you don't have any policies that are saying, because I think you said this earlier, where you're like, if a file matches these attributes, then move it into the Camaro folder. Okay.
No. Okay. We do have tools that allow you to do moves and mirrors, but I know for sure, based on the way you're describing it, that's not what you're asking
it's
about.
not the policy.
Okay.
It's not the.
We don't have a policy engine. That's the simplest way to put it.
I guess the F5 ARX, now defunct, was probably the most prominent example of like that type of policy-based movement of data and tiering, right?
Yeah. So this gives you the ability then to create a nice directory structure. We have state management for file ID mappings here that allow you to make moves behind the scenes. You want to talk a little bit about?
Sure, absolutely. I mean, so let's say someone deployed the /Camaro on their private object in-house, and then like, okay, well, we're tearing down that data center. We're not renewing our lease with that data center that houses that system. And it's okay, instead of migrating that data to some other physical data center, let's just put it up in the cloud, right? So, the approach is there. You could be, all right, well, I'm going to quiesce access to that data from the client side, and I'm going to go ahead and copy every single object from here over to the Amazon S3, for example, right? That involves an outage to clients. You have to block everybody, and it's quite inconvenient. So what we actually did is we have this Flash Move product, or it's a license that runs in our software, but basically it allows you to say, okay, I want to peel off a new bucket inside of S3, and I want you to take all the data that was on /Camaro, and I want you to move it, i.e. copy it into this new bucket. But that copy is only occurring here, and the client doesn't actually see any of that activity happening. And then every time a client creates a new file, it goes to both of those sites. And then eventually, once you've walked this entire file system and synced every file over to here, we know that that's happened because we're aware of the entire file system structure here. Then we can basically flip this switch that says no more dependencies on the Swift stack that's housing /Camaro. /Camaro now lives in S3, and the clients actually didn't have any file handles change or any state change, so they can continue to operate. And that allows us to basically background migrate data without impacting the clients. Yeah, and that gives you a lot of flexibility.
It's called Flash Move, but it's done as a copy operation.
It's done as a copy operation.
But it is a great way to do data migrations with zero downtime to your end users. We've got a couple customers who've been doing that.
And then you would go back and clean up your objects after the fact, after you've severed the dependency on that piece of data.
Okay.
Before I forget to ask the previous slide, any discussions working with Black Pearl with Spectra?
Oh, that's the tape, library. Right?
We had a conversation about a year and a half ago, but based on sort of our sales efforts and our marketing efforts, we just haven't had a lot of incoming about it. So, the upside of being able to abstract these back-end core filers is it gives us some flexibility to go into accounts and provide value. The downside can be that it's all software written by humans, and so you have to put them through life cycle. So even a NetApp or an Isilon, there can be new bugs introduced, and you have to test every major release. So there's a multiplier challenge there, that the more of those you add, the more test rounds you're going to have, the more likely you're going to have more code.
Really cheap S3 tier.
I know, yeah. No, we had that conversation. It was interesting, but it's just we couldn't add any more at this point. All right, the snapshot. So in the spirit of I have to be careful how I say this now, but we are basically providing NAS functionality to a object store backend. And with that comes great responsibility and great pain as well, right? So one of the first things that we found is we went out and we talked to folks about, you can use object, you have POSIX compliance, you can use SMB, it's great. And they said, awesome, how's your snap mirror work? Or how does it, right? So then it was like, oh, well, this is object. This isn't, you don't do mirrors. You have,
Erasure
geodispersal and erasure coding and all these other things. And they were like, I don't know what any of that means. Where's my snapshot? Fine, we'll do snapshots. And in particular, what we heard a lot about, we pulled a lot of the people that came back to us with that ask. And the use case was typically going to be, I don't want to have to go find files for my users. I'm going to go into my Windows Explorer previous versions and find the file and restore it that way. That's really the main ask. And so we implemented cloud snapshots with that in mind, is to make sure that a customer that wants to use a Clever Safe or an Amazon S3 will be able to do snapshots and be able to restore previous versions of files.
Yeah, I mean, the main driver there was the customer's like, great, love the story. What happens if someone goes to the root of the file system, does an RM minus RF, right? And that was like, okay, yeah. Snapshots is the answer to that, like to have persistent read-only point-in-time copies of the file system.
But it's not a backup tool. Right? It's very specifically purposed for that requirement of restoring files. Okay. All right, so I'm going to turn it to Bernie for a couple of slides here.
Yep.
I'll give you the vaunted pointer.
Thank you.
Talk about, this is our chunking or sharding technology for object.
Here, we have to back up for a minute.
Yeah.
So it's really interesting that you say that it's not a backup tool.
In our implementation, that's right.
Well, a number of your competitors, like once they have object and once they have versioning, even actually some of them that don't even have versioning yet, say, well, once you have your stuff in us and we've got geodispersal and blah, 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 nothing ever needs to be backed up again.
That is true at the object layer, right? What we're talking about is now we've put a POSIX abstraction that spans multiple objects in different ways, that there's no layer of correlation between what we do and the object store vendor's code. So we're just putting data there. And so we have to maintain and manage a persistent understanding of those specific snapshots, right? And they're not about like, if something goes wrong, you can restore disks, et cetera. It's more about a user has done something and they need that file back. Near real time kind of restore.
But I guess more to your point, I think what you're getting at is that the object vendors are like, you can do away with backups with this geodispersed erasure coding, because if you lose a column or you lose a disk or you lose a whole data center, your data can still be reconstructed. And that still stands with our solution, with our implementation of file on top of object with snapshots and whatnot. But the snapshots is what's adding the self-service recovery functionalities.
But taking it a step further though, like if a user is interacting with an object store and they're using a native object protocol to do something and they manipulate an object erroneously, how do you restore that in that model? Unless you have versioning.
Unless you have versioning.
Right, so I think there's a level of sophistication that's growing into these object stores. I'm not sure it's all there yet. And I'm not sure the users are all on that.
I am sure it's not all there yet.
Yeah, so there you go.
Yeah.
Okay,
so with that said, we're just to kind of give you guys an idea of why we do the things that we do with the conversion of files into objects, and the number one problem that we wanted to solve was how do we give a fully compliant file system interface out to clients that's backed by objects. So obviously you have to create a hierarchy and a relationship between all these objects, right? You have a root inode for your file system, and then you have directory objects that sit underneath that that are pointed to by the root. And then, if you're updating a directory, adding a new file into that directory, you have to update that object. And obviously, if you change 1 byte in a very large 1 gigabyte file, currently with the way that these S3 protocols work, you have to read the whole object in, stamp your 1 byte on top of it, and write the whole object out. There's no such thing as a partial overwrite per se. So what we said is, okay, since file-based workloads are typically not like read the file from offset 0 to the end of the file once and never do it again, and they're typically not writing from the beginning of the file and rewriting the whole file to the very end and then they're done. No, there's a lot more kind of transactional, more frequent access to the file in terms of maybe modifying the attributes or modifying certain ranges of a file, whatnot. Like think of a VMDK file, for example, right? There's something where you have a very large file, but you're really only updating little bits and pieces of it. So instead of having to force ourselves to update entire objects on the object store every time a client makes a tiny change to metadata or to a file, we actually broke it up into sections. And the reason that we did that was to have a metadata object that sits at the very top with a little bit of data, of the user data of the file sitting inside of it, That allows people that are looking at certain headers inside of files and whatnot to be able to fetch those in conjunction with the metadata. So when you send a stat for a file that's not in our cache that has to get pulled in from the object store, we're pulling in the attributes for that file along with the first 16 kilobytes of that file, so that when the client stats it and then starts opening it and reading it, boom, the response is instantaneous. And then at that point, we have pointers that say, okay, the rest of your user data that's stored in this file hangs off of these objects, right? So if a client comes in and modifies the 3rd megabyte range of the file, all we really have to do is overwrite one, change one object inside of the object storage instead of having to rearrange and reshuffle all the objects or an entire large object in that case. The same thing goes with the directory structure, where we have the directory entries inside of this directory object. And basically, when you get into really large directories, things can get complicated in terms of, like, if you shoved all these directory entries into a single directory object with 1 million directory entries in there, and someone went to go add the 1,000,000 first, now you got to reparse all those 1,000,000 objects, figure out where that one fits in, rewrite the object back out. So we do a similar chunking of the directory structures as well, because we do have customers who really do some strange stuff with many millions of files. And you're like, why are you doing that? And they're like, that's how we do things. So you have to be able to handle kind of that level of granularity and precision when manipulating these structures. Otherwise, you end up fetching a lot of data from the object store, making a change to it, and pushing it all the way back out. The other interesting piece that's important to bring up is stuff like directory renames and hard links. Right? A hard link is just adding an entry here and pointing it at the object of another file, instead of actually, there's no way to really truly support a hard link in an S3 only environment. Or another case where, like I mentioned earlier, is if you rename a subdirectory that has 1 billion files underneath it, that is just 2 updates in terms of changing a directory pointer and putting the new object and cleaning up the old one.
Do you run into any limitations on the back end where, like, because of the way you're doing this, you're creating 8 billion objects instead of 10,000 files?
I would say I wouldn't say we're running into issues. I think that our customers it's more of an issue for the private object stores. Right. The public object stores, as far as I'm concerned, are very effective at ingesting a multitude of billions and billions upon billions of objects. Some of the private object vendors, they have limits, stated limits. So then we are aware of those limits, and then we keep track of how many objects we're putting out there, and basically keep you under that limit, right?
Can you then just make another bucket, or you
can create another bucket, but you can create another bucket, and then that is basically another branch of the file system, though. So there is some planning that has to take place in terms of knowing what the limits of your private object storage are, and what the topology of your data is, and the eventual growth rates of your data. But a lot of the object vendors have kind of, at least from our experience, have seen that these object count limits are an issue. Yeah. And they've been making steady improvements towards the number of objects that they can support per bucket or per vault. Or
the vendors we work with have been growing the counts over time. Right. Still not where it needs to be, but it's getting there. I can't think of a specific implementation where we've run into that, though. Like a hard, like customer calls, it's all broken, we hit the max limit. Hasn't happened yet.
So I mean that's and then the other interesting piece also is our ability to do parallel fetches of read-ahead data. So if you have a really large file here that's not, let's say it's 3.5 gigabytes instead of 3.5 megabytes, when a client comes in and starts reading it, we actually can pick up on that pattern that it's like, oh, he started at the beginning of the file and he's starting to read pretty aggressively through that. And we can fetch, since we have lists of all the objects that represent a certain file, we can actually send the gets all in parallel for all those objects, wait for them to come back, look at how the client's doing in terms of reading across all the data represented by those objects, and then go back and turn around and start fetching the next batch of objects. And that is what really helps you mitigate the bandwidth delay product that you're overcoming when you're going to public cloud, or even just the general slower response time that you get from a private object store versus something like a high-performance NAS device. So, just like you brought up at the very beginning, one file does not equal one object, right? It's obviously something that everybody has to be aware of. And then as Scott mentioned, snapshot functionality from NFS, you just have like a .snapshot directory that's available anywhere in the namespace, and you can cd into .snapshot and then see your previous versions of directories and files in there. And then through SMB, it's just the Windows Explorer previous versions type functionality, or what do they call that? Shadow copy or something like that. VSS.
VSS.
It's really just previous version.
Yeah, previous versions. Right.
Previous version client.
And then essentially, as clients start to append to files, all we have to do is allocate new objects, update the pointers on the main object, and start just stringing them along. And obviously, we have support for variable length objects here because we actually compress the data before we push it out to the cloud. I mean, if you have compression enabled, which basically allows us to say, if a client writes a 1 meg file to us that is not compressible, you're going to see 1 meg object get put down there. But if it's a text file that's highly compressible, we're going to put 100 kilobytes or whatever it compresses down to in the object. So even though each object represented a 1 megabyte range of offset data, it's actually can be much smaller when it sits on disk.
Is that tunable at all? Because some of the object stores are really inefficient at storing small objects.
The object size, it is tunable.
Yeah. Up to 8 meg.
Yeah, so we basically use the 1 meg object size for public and 8 meg object size for private, because the private guys were more intent on getting larger, fewer objects.
Bear in mind, you're chunking your objects up like that. You've got the option to do dedupe, surely, quite easily.
We don't currently support dedupe.
That wasn't what I was asking the question. I was saying you technically have the option to do it quite easily.
You could, but we don't do anything willfully.
It is a good. That's the opportune time to do it, right? Is when you've found a common piece of data and getting ready to push it out.
Why aren't you doing it? If it's if you've already got the information currently.
a lot of the demand has been more for the computational workloads and less for the backup space, which is typically where we were hearing about dedupe a lot. So it's really no more than that in terms of decision. Finite engineering resources, finite time, priorities.
Yeah, the overload for primary data dedupe is, it's a lot more value in the backup space, right?
Yeah. That was really it.
We've also come across some backup vendors that have started doing the dedupe on their agent, quote unquote, server side, which kind of also reduced the pressure that we were seeing from the field for any of those.
And things like your media isn't going to dedupe particularly well anyway.
Right, and media is typically working with pretty small files, and like every version of a file that they create is different. So there's not a whole lot of overlap. And then the output files are all bitmaps, which any one color change or anything across that makes an entire chunk possibly not dedupable.
Okay.
All right, and then the last piece is obviously these snapshot objects that we were talking about, which our file system layer knows how to interpret, but they're basically just other objects that sit inside the object store that point to the golden versions of the files, the read-only versions of the files that aren't being modified. And then those relationships get modified when you clean up old snapshots. They're not actually modified when you create new snapshots.
I think that was just a
good old animated slide.
Sorry.
Flash move, flash mirror. You want to talk?
Yeah, you can go ahead.
Okay,
it's fine.
So we mentioned this before. I guess we got a little bit about ourselves, so we don't have to rehash it all. But the whole idea was, okay, if you wanted to migrate either on-prem NAS data, file data, or an on-prem object bucket somewhere else, we have the functionality to do that, where the perception of the client. The perception that the client has of the namespace and of the file system structure does not change. And that's super important to customers that are dealing with really large data sets that would take really long time to move, that have active applications running against them all the time.
Yeah. That has animation too.
Ooh, fancy.
There you go. I mean, the mirror case is actually one that we hear a lot about and people do use because they're able to then sort of DR off into Amazon. We have customers right now that are looking at using it between two of the major public cloud providers.
Yeah.
Right?
What percentage of people are doing that?
A low percentage today, but I think that's probably going to change over time.
Do you have any? Do you then collect any performance statistics for those customers?
Well, so in what terms performance? Sorry, I'm not.
Well, I'm thinking of another vendor who they did cloud caching and mirroring, right? And for example, they noticed before. Stephen, what was my favorite San Diego cloud company where you used to work for? I can't recall. You can't recall, yeah. That company, anyway, the San Diego cloud company that disappeared.
Nutanix.
No, Nirvana, thank you. Nirvana that just disappeared. They noticed up front that something was funky and had, basically made sure that everybody's data was already in another cloud. So when Nirvanix went offline, it was not an effect for those customers.
Oh, you're saying, do we do monitoring of the performance of the actual mirroring relationship to say this is no good anymore, stop using that?
Yeah, or there's a concern or, whatever.
Yeah, we do some flagging of that.
Yeah, we have dashboard views that allow you to see kind of, okay, how effectively, so in a mirror relationship, how effectively am I pushing data to my on-prem copy of the mirror versus my cloud-based copy of the mirror?
Right.
We have, the ability our software will tell you if the cloud starts lagging behind, for example, if the quality of the link is wrong or something like that.
We have those stats. We do work with customers now and think about it, that we help them build views of those stats that then can inform them on the quality of the
For some reason, Amazon had slowed down, maybe because, Google has
everybody started watching Netflix at 5 p.m. or whatever,
It does, that happens. Yes. Okay. So yeah, we definitely.
Yeah, I mean, I think the mirror case is actually really interesting for people who they want to maintain on-prem NAS and they're like, I just want to keep an extra copy of that data in the cloud should my on-prem NAS catch fire or something like that. And they can essentially perform that mirroring in real time. And if they wanted to, let's say, deprecate their on-prem NAS and deprecate their edge filer, they could spin up all their compute processes in the cloud, pointing at that copy of the bucket, and you're good to go.
Okay, so then this is just a recap of sort of the feature set to give you a feel. We talked about the edge core architecture where we sit close to the compute. We talked about scale out. So every node's going to partner with another node in the HA relationship. It's an election-based system. If something goes down, there's a reconvergence. The Flash cloud file system, which Bernie talked about, the different objects. Our global namespace, and the Flash Move tool that allows you to move things. Cloud snapshots, Flash Mirror. We do support AES-256 data at rest encryption for objects only. We support KMIP. We did do the work with OpenSSL to make sure that we recompiled in a FIPS container as an option for the government. Hopefully they hear that. LZ4 compression. And somebody just was like, noted. All right, I got them. LZ4 compression for our data. And then, like I said, we do have the physical and the virtual FXTs. We have 3 models, and I have a slide down the line that'll show you the different models. And, marketing claim at the bottom, lowest TCO. Depends on your use case. There are definitely use cases where we will help on the TCO. This is our powerful analytic GUI. Ooh. Yeah, so I will say our product has a wealth of stats, and the UI and the API both provide mechanisms through which you can mine those stats and find out pretty much any little nuance of our product. Because again, this product was born out of performance, and so the more you know about your internals, the better it could be tuned. Okay. Oh, animation. We do give you information about the cache and how it's distributed across the different core filers that we've configured so that you can see what's available and what's free for consumption. These are our models. So in the virtual world, we run Google HiMem 32, HiMem 8. You may ask, why are we only running 2? The answer is we test.
You're only running 2.
We test. And so we can't test every variation. And since we are a performance-based product, there are definitely differences depending on what type you run. For example, in Amazon, the R3 8 extra large supports 10 gig networking. The R3 2 extra large does not. Many of the other instance types in Amazon do not support 10 gig networking. And so you're not going to get the same performance characteristics if you aren't using it. And then in Azure, right now we support the DS13. We're going to be looking at potentially revving that to V2 of DS13. And then on the physical side, we have 3 models. The 5200 would be used typically for your cloud gateway, for your archive, active archive use cases. And then the 54 and 56, you would look at using for your performance tier. And then depending on how much, the way to think about it is it's a price game between the amount of memory and the amount of disk, which is really about the amount of your working set that you intend to keep warm at any given time.